Welcome to this video on matrix inversion. In this video we are going to answer the question, what is the inverse of a matrix? We're going to learn about the notation for the inverse, learn how to find an inverse, and finally we will use matrix inversion to solve a system of equations. When we have two matrices that are inverses, they have a special property. And these two matrices are inverses, so let's see what happens. When we take these matrices and we multiply them together, remember how this works. You're going to take the rows of the first matrix and multiply by the columns of the second matrix. So we're going to take 1 times 2/5, that's 2/5, plus 3 times 1/5. For this element here, this second element here, we're going to take 1 times -3/10, so that's -3/10, plus 3 times 1/10, that's 3/10. For the next row, we're going to take -2 times 2/5, so that's going to be -4/5, plus 4 times 1/5, that's 4/5. And then finally for this element here, we're going to take -2 times -3/10, so that's going to be +6/10, plus 4 times 1/10. So let's do a little simplification here. 2/5 plus 3/5 is 5/5, so that's 1. -3/10 plus 3/10 is 0. -4/5 plus 4/5 is 0. And 6/10 plus 4/10, that's 10/10, which is 1. So this matrix is that special matrix that we call the identity, where we have ones along the diagonal and zeros everywhere else. So whenever you have two matrices A and B, where A times B equals the identity, and this will happen that B times A will also equal the identity, then we say that these matrices are inverses of each other. And so instead of writing B, we write A, and then it looks like it's to the power -1, but we don't say that. We say A inverse. That's how we describe that. So instead of writing A times B, we would say A times A inverse equals I. Now if you're unsure whether two matrices are inverses of each other, all you have to do is do this multiplication. If you end up with the identity, you know they're inverses. So next let's look at how to find an inverse. So first we're going to talk about how this happens, how we would go about finding an inverse if we didn't have a calculator to do it for us, or if we didn't have a method. We're going to learn an easier method in a second here. But if we wanted to find the inverse matrix of A, so this is my A here, if I wanted to find the inverse of that matrix, I would find this other matrix, and let's just call it XYZW, and we would want our matrix A times our matrix B to equal the identity. So if we did the multiplication here, we would have, I'm just going to multiply the A times the B, I would have 3x plus 5y, that's this row times this column, and then I'd have 3z plus 5w. For the second row, I would have 2x plus 1y, so that's just 2x plus y, and finally 2z plus 1w, and we would want this to equal the identity. So this brings up two basic systems of equations. One system of equation would look like 3x plus 5y equals 1, and 2x plus y equals 0, and the second system of equation would be 3z plus 5w equals 0, and 2z plus w equals 1. Now those two systems of equations, we've solved those things before. We could solve them using probably the substitution method, or we could solve them using elimination, or we could solve them by putting them into our matrix and as an augmented matrix, and then do our REF on them. Notice here that the coefficient matrix here and the coefficient matrix here are identical. So if you were actually going to find the inverse, if you didn't have the calculator to do it, or if you didn't have another method, what you would do is you would stick your coefficient matrix over here, and then over on your right hand side, instead of just doing two separate problems where you did one with 1, 0 and then you did the other with 0, 1, you would start with this augmented matrix where we have two right hand side, and then we would do our REF on it, and we would get the identity over here, and we'd get the inverse over here. So if you were doing row operations in class, you would do the row operations to turn this matrix over here into the identity and this over here into the inverse. Now luckily for a 2 by 2 matrices we have a quicker, easier method, and then we can always use our calculator to do these for us too. Okay, so let's learn a really quick and easy way to find the inverse of a 2 by 2 matrix. First of all, not all matrices have inverses. There's some matrices that we can't find an inverse for. And the way we tell whether we can find an inverse is by looking at the value of what's called the determinant. So if we have a matrix that looks like this, what you do is you take A times D minus B times C. So the example that we were looking at just a second ago was the matrix 3, 5, and then 2, 1. So our determinant, we would take 3 times 1 and subtract off 5 times 2. So this gives us 3 minus 10, so that's negative 7. So as long as our determinant is not 0, the inverse will exist. So this matrix does have an inverse. So now we know that it has an inverse, but we want to actually be able to find the inverse. So we have a little method here for a 2 by 2 matrix. This doesn't work for bigger matrices, but it works really nicely for these small square ones. What we do is we first swap things that are on the diagonal. So instead of having 3 and 1, we're going to put 1 and 3. Second, we make the B and the C negative. So instead of having positive 5, we're going to have negative 5. And instead of having positive 2, we're going to have negative 2. And then lastly, we divide by the determinant. So I'm going to put the determinant here is negative 7, so I'm going to divide by negative 7 by multiplying out here by negative 1/7. And so we get the matrix negative 1/7, positive 5/7, positive 2/7, and negative 3/7. So let's see how to find this on our calculator. So if we were going to find this on our calculator, we would first go into our matrix screen, and I am going to edit this 2 by 2 matrix, and I'm going to put my original matrix in there, and then I'm going to quit out of this screen. And if I want to do the inverse of matrix A, first I'm going to go grab A, so I'm going to put matrix and I'm going to grab the name A, and I'm going to use this button that looks like it's got to the negative 1. Now remember that this doesn't actually mean I'm raising my matrix A to the negative 1 power. We don't really have that defined. What it does mean is I'm going to find the inverse of A. So this is what my inverse looks like. But remember, I want to see these numbers. I want to know what it is in terms of fractions. So all I need to do is press Math and tell my calculator to turn everything into a fraction. And looky here, we got the same exact thing. Everything matches. So one thing that I haven't mentioned that's pretty helpful to think about is when we're talking about, we talked about how some matrices have inverses and some don't. So the only possible matrices that have inverses are square matrices. So only square matrices can have inverses. Now, that doesn't mean that all square matrices have inverses. It just means that some square matrices have inverses. And if it's not square, so for instance, if I look at this matrix, this will not have an inverse. So if this is my matrix A inverse does not exist. If it's not square, there's no possible inverse for it. So let's look at this one last problem. If we want to use an inverse in order to solve a system of equations, we can. First, let's remember how we can write this system of equations using matrix multiplication. My coefficient matrix is this matrix 1, 3, negative 2, 4, and then I can multiply that matrix by a column vector, which is my variables, and that's going to equal my right-hand side. So what I have here is I have my matrix A, which is my coefficient matrix, times that column vector x equals my right-hand side. And so I'm going to write this as AX equals B. So if I had something like this, let's change it a little bit. If I were thinking about this in terms of more just a number problem, like think way back to algebra. If you had AX equals B, or if you want to use real numbers like 2x equals 3, then you could solve this pretty easily, right? All you needed to do is get rid of this 2, and so one way we would get rid of that 2 is we would divide, right? But we don't have anything like division for matrices. We don't have a way to divide two matrices. However, we do have a similar idea that we've just been talking about. So remember that the multiplicative inverse of 2 is 1/2. So we could multiply by 1/2 on both sides and get x equals 3/2. So that's what we're going to do over here. So we're going to take our AX equals B, and we want to get rid of this A here. So I am going to multiply on both sides by A inverse. Now, with numbers, it doesn't really matter how you multiply because 3 times 2 is 2 times 3. But with matrices, it does matter because sometimes if you multiply one way, it's defined, and if you multiply the other way, it's not defined. So what we need to do is we need to make sure that if we multiply on the left by A inverse, we got to multiply on the left over here by A inverse. Otherwise, it won't work out. Now, remember we talked about A inverse times A? That is our identity matrix. So we have the identity times x equals A inverse times B. And remember how the identity works. When you multiply the identity times a matrix, you get itself. So we get x equals A inverse times B. So what we're going to do is we are going to take this idea here and use it to solve this system of equations. So this here is my A, that's my x, and that's my b. So to solve for x, what I need to do is do A inverse times b. So I'm going to go ahead and just do this on my calculator. So I'm going to put in my matrix A, my matrix menu. I'm going to choose A to edit, and it's a 2 by 2 matrix. So there's my matrix A. We're going to make it the inverse in a second, and then we're going to quit out of here, and we're going to go back and enter the matrix B. So I'm going to choose matrix B to enter this time, and this is my matrix B right there. So it is a 2 by 1 matrix, and we have 5, -3. Quit out of here. So our answer is A inverse times B. So we're going to take our matrix A, get the name there, make it the inverse. So I'm going to hit this little X inverse button and multiply that by my matrix B. And we get X equals 2.9, 0.7. This is what my X equals. This is a big capital X. So that tells me my little x is 2.9 and my y is 0.7. That's it for this video.